Today we're doing section 8.5, which is writing tangent lines. So in order to write an equation of a line, as we know back from Algebra 1, we need to know two things. We need to have a point, and we need to have a slope. And so just the last day or two, we have been talking about how do we find the slope of a tangent line. And so when we talk about that word derivative, derivatives are just slopes, and they happen to be the slopes of tangent lines, which is win-win for us in this lesson when we want to know slopes of tangent lines and points on tangent lines. So here it says we're going to write an equation for the tangent line in each given situation. Please leave your answers in point slope. So just a reminder that this is what point slope looks like. I don't need to put it in y equals mx plus b. I don't need it as a y-intercept. M is my slope, x1 and y1 are my ordered pair. So here it says write an equation for the tangent line of f of x equals 2x plus 3 at x equals 1. So the first thing we need to know is what's the point. So if I'm going to plug in x equals 1, 2 times 1 plus 3 is 5. So now I've got my point, and now to find the slope at x equals 1, we need to do the derivative to find the slope. So let's do that work over here. F prime of x is derivative of this. If I take that 1 down, so I get just 2. Now, I can't really plug in 1, but f prime of 1 is going to be 2. So now I've got a point, I've got a slope. So now a tangent line equation, y minus y1 equals m x minus x1. So now number 2, same thing, I just didn't give you all these little scaffolds here. So I've got this function, and this is at x equals negative 2. So first thing we need to know is what's the point at negative 2. So I plug it in, negative 2 squared is 4. 20 divided by 4 is 5. Now I also need to know what the slope is at x equals negative 2. And to do the slope, we do the derivative. Now this is not in a nice form, and so I'm going to rewrite this function so that it's a power rule type of a question. And instead of it being x squared on the bottom, I can write that as a negative exponent. So x to the negative 2 is the same thing as x squared on the bottom of the fraction. Now it's an easier function for me to find the derivative of. So we get negative 2 times 20, which is negative 40, x to the, now we drop this power by 1, so what's negative 2 minus 1? So we get this to the negative third. Now you don't have to rewrite this, but that's written as negative 40 over x to the third. And now I look back over here and I know I'm supposed to find the slope at negative 2. So now we need to do negative 40 over negative 2 cubed. So negative 2 to the third power is negative 8. Negative 40 divided by negative 8 is 5. So now I've got my point, I've got my slope, that's everything I need to know. So my equation of my tangent line, y minus y1 equals m x minus x1. And you can leave it as minus negative 2, but I changed it to plus. All right, I want you to try number 3. So our ordered pair, remember when you do this, you can cube root 8, which is 2, and then 2 to the 4th is 16. My function is x to the 4 thirds, so if I bring that power down and then I subtract 1, I'm subtracting 3 over 3, which is 1 third. And then we find that slope at 8. So the cube root of 8 is 2 times 4 thirds is 8 thirds. And so our function y minus 16 equals 8 thirds x minus 8. Have a great day.